What's up, guys? My name is Michael and welcome to my YouTube channel. So the other day, there's two things I forgot. There's basically something called inline functions. If you call a function like 10 times, the program like normally jumps these executions, and then once the function returns, it jumps back to the next line, right? But if you call a function 10 times, the program jumps to the same set of instructions each time. So a better way to increase efficiency is actually use something called inline functions. And these inline functions, it copies the code from the inline function directly into the calling function, so it makes it more efficient. So you don't, when you jump 10 times, you make one copy, so then you could go directly to, this is a good, if you just want to like have a simple like function that like, such as like multiplying twice, right? Just return something that multiplies it by twice too, and then you have like put inline in front of it, and basically it just makes it faster. Now the thing is that this actually could make it slower. So this is the thing that I just didn't want to include it. If you call this function 10 times, right, the inline code is copied into its calling function each of those 10 times. So with large programs, this might actually decrease speed, even though it increases efficiency in these small programs. So I didn't even want to go over this, but pretty much if you create like a, this is easy. Like, oh, I'm just doubling a value, right, and then I'm just printing it out the value. Right, this is easy because like it's just one line, but sometimes the putting inline in front of functions might actually make it even slower. But if it's like just a one line function, it might actually make it faster. So boom, it's 6. You should use inline functions just if you know that it's like, oh, it's a small function, it doesn't do that many things. So then it makes the execution faster. But for large programs, just don't include inline. Alright, the second thing that I forgot to talk about is passing by value in functions, which is very important. So let's say I have a function called swap, and I want to swap two variables called a and b, right? Basically, here I'm going to swap two values, a and b, right? So normally you would think that, oh, okay, if I have int x as 3 and then I have int y equals to 4, right? And I want to swap these values. I just pass x and y, and then here I'm going to print out the values of x and y. So the value of x is x and L. Then let me just copy this. Value of y is, and then I do y. So this is going to be before function call. Alright, now I swap them. Then I'm going to print after function call. And then I'm going to print these two values again. So okay. So I'm going to swap the values of x and y. And to do that, you would think that, okay, so in order to swap them, I just create a temporary variable, set it to have the value a, right? Then I set the value of a to have the value of b, and then b to have the temporary variable. Ideally, this should swap these two values. But look what happens when I run it. Before function call, value of x is 3, value of y is 4. After function call, value of x is still 3 and the value of y is still 4. Now, why is this? The reason is because when you pass values into functions, these variables don't get changed. You know why? Because everything is passed by value. In functions, a and b now have copies of the values of x and y. X and y are not changed, okay? So x has a value of 3, y has a value of 4. These are two integer values, right? And then I print them out. I pass them into swap. So now a has a value of 3, and b has a value of 4, okay? Then I create a temporary variable, have it set to a, which is 3, a to have the value of 4, then b to have the value of 3. So now a may have the value of 4 and b had to have value of 3, but then after this function call, everything gets wiped out, okay? And then these values stay the same for x and y. If you pass them into functions, they are just copied. I don't have the value x and I changed it into this function, okay? It's not like I have the value of x in here and I changed it, okay? It's not like a global variable. I have the value of x. I passed it in to this function swap, and then a now has the value of x, which is 3. Then b has the value of y, which is 4. So a and b are completely different integers. So whatever's changed here doesn't affect x and y. Do you understand? Okay. So that's basically passing by value. Variables passed into functions do not get changed after the function call because they are copied. They're not the actual variables. Now, this changes when we get into pointers, but for now, it just doesn't change. Your variables do not change at all when you pass them in, okay? In the function call, you change whatsoever, it's not going to get changed after the function call because everything gets. So there's another thing that I want to talk about that I didn't really get to talk about before. This is the concept of recursion. So recursion is basically calling the same function over and over again, but you're changing the parameters until you hit a condition for your parameters. So let's say I want to find the Fibonacci of some number. And if you remember what Fibonacci is from grade school, it's basically just you start with the value 1, 1, and then you add the previous value to it. So you have 1 plus 1, then it's 2. Then 1 plus 2 is 3. Then 2 plus 3 is 5. Then 3 plus 5 is 8. And then 8 plus 5 is 13. Then 13 plus 8 is 21 because you're adding the previous two numbers. Recursion is basically calling the same function over and over again until you reach a condition. And when you call the same function over again, you're changing your parameter. That's all it is, okay? Once your parameter hits something, you stop. That's basically all what recursion is, okay? So basically, if I want to return the Fibonacci of the number, let's say the fifth value, so 1, 2, 3, 4, 5, right? And that's 5, okay? I'm going to first return fib. I want the previous two, add up the previous two values. So that's number minus 1 plus fib number minus 2. And I know this is because it's the previous two values because it's based on your parameter. You change your parameter, you call this function again, and you change your parameter. Now, then if the number is less than 3, then I return 1. So this is what's going to happen. So if I put fib of 5, right? So I'm going to call fib of 5. It's going to go to here. 5 is not less than 3. So I'm going to return fib of 4 plus fib of 3. Those are the previous two values, right? So then I call fib of 4. So now here here's going to be the value of fib of 4. The fib of 4 is equal to, for fib of 4, 4 is not less than 3, so I'm going to return fib of 3 plus fib of 2. Fib of 4 is going to equal to fib of 3 plus fib of 2. It's going to call fib of 3. So over here, it's going to call fib of 3. So fib of 3 is equal to fib of 2 plus fib of 1, right? Then it's going to call fib of 2. So I go back up here. 2 is now less than 3. So we know what that is. It returns 1. So this is equal to 1 plus then fib of 1. 1 is less than 3. It returns 1. So that's 2. So then fib of 3 is 2. So now it goes back up to here. Fib is equal to fib of 3, which is 2, plus fib of 2. We know what fib of 2 is. It's 1. Fib of 2 is 1, right? Because 1 is less than 3, so it returns 1. So then this is going to equal 2 plus 1, which is equal to 3. Now we know what fib of 4 was. We go back to this side, return fib of 4, which is 3. Now we add fib of 3. We calculated fib of 3 already. It's 2. It's going to equal to 3 plus 2, which equal to 5. So then after this, it returns 5. So then fib of 5 is equal to 5. So that's basically how recursion works. You keep calling the same function over and over again until you hit a condition. Now you probably will never ever have to use this because this is actually very, very inefficient because you're calling the same function over and over again. You're basically hitting the stack frame over and over again. Now here's the problem. If I don't have this condition, then it's just going to keep calling this function. Fib of number minus 1 plus fib of number minus 2. If I just commented this out, then I'm going to get it like an overflow. And I print out fib of 5. Fibonacci of 5 is, I'm going to get, if I don't have this base case, I'm going to have an error, see? And then it's going to stop because look how many my call stack. I'm literally calling the same function over and over again. And that's really bad because it doesn't stop. So that's why you need to have this base case. So part of figuring out recursion is basically figure out your base case and figure out what you're recalling the function again. You basically have to figure out what am I changing for my parameter. It's all you have to figure out. And then after that, you have to figure out what is my base case? What what case does my parameter hit something, then I return something and stop the whole recursive call. That's basically how recursion is. You change the parameters, you keep calling the same function over and over again, but you change the parameters. So then this function is going to return a completely different value. So that's basically it. Like every time, because you're changing the parameter, your function is going to return a different value each time. So that's basically what recursion is. Now you probably will never use this because it's very inefficient, because you push something onto the stack over and over again. You're basically calling this function again and again and again. That's really inefficient. But there's a better way to do this using loops. We'll talk about that. Yeah, so Fibonacci of 5 is 5. Fib of 5 is equal to 5. And if you do like fib of 1, 2, 3, 4, 5, 6, 7, 8, it should give 21. So fib of 8 is, yep, Fibonacci of 8 is 21. So that's basically what recursion is. Keep calling the same function over again, change one of the parameters, and then for the base case, once your parameter hits something, gets less than something or does something, then you return a value. Like you want to return a value to stop it all. Alright, so this base case might vary each time, but that's basically what recursion. Alright guys, now we're going to talk about object-oriented programming. So basically, it's easier to describe people's programs in terms of objects, because in the real world, there's objects. Like there's a cat, there's a mouse, I don't know, trees. It's easier to represent these in terms of objects, because you could write larger programs, you could solve problems if you do that, instead of doing procedural, which is line by line. So before C++, there was a struct that allows you to group variables together, but now it's actually way better to group code together in forms of objects rather than just struct, because you could also have functions. So they created something called a class. Basically, a class is a collection of variables of different types combined with a set of related functions. So like a car has a set of wheels, doors, seats, and windows, but the car can also speed up, slow down, stop, park, and so on. So this is a class and enables you to encapsulate or bundle these things into an object. Class can also consist of any combination of variable types and other class types. So you could have a class of a car, and then you could have inside that, you could have a variable of a type wheel, which is also another class. Class can also contain functions and member functions or methods, and member functions manipulate member variables. So remember, you need to have good variable name. Your variables should hold meaning at all times. Like don't have like int x. Don't do what I did in int x equals 8. Let's just define a class together, cat class. So basically put class, then the name of your class, which is cat, 2 braces, and then a semicolon. So this defines the template for the class cat. So we're gonna have a variable called age. A cat has an age. And then we're going to have a variable called a weight. Cat has a weight. Whoops. They're unsigned because they're not going to be negative. Like you can't have a negative weight. Then we're going to have a cat can meow, which is a function. And then a cat can. Let's just do scratch also. It could scratch with its claws. Now in main, we could define an object of type cat. Let's call Mr. Frisky. That's his name. Okay. So an object is an instance of a class. Basically, a class holds the definitions and the definitions, such as the definitions of a cat. The individual object is Mr. Frisky. That help you know when you make cookies? A class is basically the cookie cutter. Each object are the individual cookies. You know what I'm saying? So the class cat holds a template to create each individual object of whatever name you want. So like cat, let's say Snuffles. They're different objects. The cat allows me, which is a template for your object that allows you to create multiple instances of the object. An object is an instance of a class. So, Mr. Frisky is an object, which is an instance of cat. Snuffles is another object, which is an instance of cat. To assign values to an object, you use the dot operator to access the members of the object. So Mr. Frisky dot, if I want to get the age, it's the age to whatever. Oh, okay, wait, okay. I have to make this public. We'll go over that. If I want to have meow, have it meow, I use the dot operator to make it meow. And then if I want to scratch. I don't know. Just call scratch. Use the dot to call each individual. I just want to make it very clear that you don't assign values to classes. You assign values to individual objects. So, for instance, here I made an object of Mr. Frisky, and added Mr. Frisky.age equals to 10. Then I called meow and scratch. This is what you're supposed to do. You're not supposed to do cat.age, because cat has no age. It's the class. You're supposed to do, you assign values to each individual objects, not classes. Okay? There's another thing you need to go over. If there's no method or variable inside the class, you can't call it that. So if I set like dot claw or lives, Mr. Frisky.lives equals this 1. There's no variable of lives inside cat, so you can't set it equal to 1. Okay. Or if there's no method, let's say die. Okay. There's no die inside cat, so you can't call it. I'm just trying to make it clear. All right, guys, now I'm going to go over private versus public. So bear with me. What private versus public is. It's basically private means that you could access it only by the methods of the class. Public means it could be accessed through any object of the class. So for now, I made all of these things public by putting this public sign here. This meant that in main, I could access all of these things. Age, weight, meow, scratch. I could access the object for Mr. Frisky. All of these values, I could set Mr. Frisky.age equals 10, .meow, .scratch. But if I set this to private, I'm not going to have access to any of these. Age, meow, and scratch. Because private means that I could only access them inside the methods of cat. So that means that I could have another method, get age, unsigned int get age, and this could return age. So then the only way to access it is having a public method that allows me to return age. Mr. Frisky dot get age. Let me just delete these. So if I want Mr. Frisky's age, I have to use a separate method for cat, separate public method for cat that allows me to get the age. Now you might be wondering, why does it matter? Why do we have private variables? Because sometimes you don't want other programmers to have direct access to this variable. Sometimes you don't want them to change their values for age and weight, because sometimes, like, let's say if another programmer sees my code, right, and he said, oh, okay, and he accidentally changes the age and weight, then if cat wasn't cat, but it was like a space program or something, and the values can't be negative, and you had to like launch a spaceship into space, right, and then now you have the negative values of oxygen or something, that could really screw up other people's program. That could really screw up the things. So that's why we have private. By default, private can only be accessed through the methods inside cat. So if I have another method called unsigned int add age, here I could just add age, because private, I could access these values in other methods inside cat, but I don't have access to it outside of cat. So this helps data hiding and helps a lot of things. By default, all methods are private by default. So if I take this out in C++, all these methods are private. Do you see these? Meow, scratch, and everything. If I do Mr. Frisky dot scratch, I'm gonna have an error because it's private. Other people can't see it. Outside of this class, nobody can see what scratch is, okay? Even add age. It's all private. All these values by default are private. The variables, the methods, they're all private, unless you put public in front of it by doing this, public colon. That's when you could now add age. Private means they could only be accessed by methods of the class. So inside cat, I could access all these private things, but outside of the class cat, I can't act. So if you make your data members private, you should allow access through it using other public methods called accessors. The reason why we use accessors is that it enables you to separate details of how the data is stored from how it's used. By using an accessor, you can later change how the data is stored without having to rewrite any of the other functions in your program that you use the data. So here, I'll show you. So if age and weight are private, I want to set the age and weight, I want the programmers outside to set it, then what I do is I create accessors, public methods called accessors, get age, unsigned int get weight, return weight, unsigned int, no, this is going to be void, set weight, pass in unsigned int. I set weight is equal to w, void set age, So these are accessors that allow me to get the values that are private for weight and age. And that's basically how you do it. So then here I could do Mr. Frisky dot set age. I could set the age of cat to have 2, Mr. Frisky. I could do set weight, set his weight to be 100 pounds. I don't know, he's a fat cat. And then, yeah, then I could get the ages. So basically I just print out Mr. Frisky's age and weight. Mr. Frisky's age, and then print out Mr. Frisky's weight. Now run it, and boom, Mr. Frisky's age is 5, and then his weight is 10. Wait, did I change it to? I think I changed it to 10 by accident. It should be 100. See, the fat cat, his weight is 100. Easy. And that's basically it. That's what accessors are. Before I talk about constructors and destructors and how you should structure your code for objects, I'm going to talk about something called const. If you declare a method const, you are promising to the compiler that you won't change any of the values of the members of the class. So you should actually do this for accessors such as get age, get weight. These just return the values of the instance variables of age and weight. So for instance, if I make this const, all you have to do is put const at the end and then const at the end. These are good because they force you to basically saying, oh, okay, this method cannot change anything of the value age or weight, so therefore you should make a const. If you make something const that shouldn't be const, like this changes the value of weight, so you can't make this const. The compiler will flag you. So that's the good thing about it. In get age, if I say it's const, then I change weight, it's gonna flag me also, because const means that you're not changing any of these values. You should do this because const basically says, okay, you're not changing anything for this method, so it makes it clear. All right, guys, so now I'm going to talk about constructors and destructors. So basically, you know how normally before you could create an integer x and then you set x equals to 5 integer variable, and then we initialize it to 5. Well, you know that you could declare the variable x and initialize it to 5. Well, that's the same thing in terms of objects. So here in Mr. Frisky, rather than creating an object of Mr. Frisky and then setting the age and weight, there is actually an easier way to do this. All you have to do is just have a constructor, which is an easier way to set up your instance variables and initialize them. To create a constructor, you basically just write the class's name, cat, which is a method. There's no return type. That's the difference about constructors. And then you pass in the variables a and w for now. Then you set the variables, your instance variables, to those variables. Now when you create Mr. Frisky, you could easily just do this with a constructor 5 and 10. So now I could just comment these out, and now when I run it, it's the same thing as 5 and 10 when I print the age and the weight. Age is 5, weight is 10. Let me just talk about destructors first. You should also include something called a destructor, which is deallocates memory for your thing. So it's normally called all the time right after your thing. All you have to do is put a tilde sign and then the name of the class, cat, and that's basically it for your destructor. It deallocates memory. When we get to pointers, then we might start talking about destructors because these actually are very important. For now, just leave it empty. Now let's talk about default constructors now. Before we created a constructor, in C++, it's given to you already called a default constructor. And a default constructor basically is a constructor that takes no arguments. So if you didn't have this constructor, let me just comment this out. If you didn't have this constructor, to initialize your cat, before you just do cat Mr. Frisky, and that actually just called the default constructor, which is a no argument constructor. It's a constructor that had no parameters in it. You could actually have multiple constructors. This is called constructor overloading, and then when you call Mr. Frisky, it would call the default constructor. See, this should have age of 10 and weight of 100. See, so to call the default constructor, it's automatically called for you. You just create your object like this. That just calls the default constructor. Now, when you write your own constructor, which is what I did right here, it actually overwrites the default constructor. Say if I take out this default constructor, right, int a, int w. So I wrote my own constructor, so now I don't have default constructor. Then it's going to give me a compile error. No default constructor exists for the class. So if you write your own constructor and it's not the default constructor, If I write a constructor with arguments in it, it overrides the default constructor. So I don't have a default constructor. Now, if I didn't include my own constructor, then I could still use a default constructor because it's automatically given to me. Now, it doesn't really set anything because when I get the age and weight, it's probably just going to be garbage, see? So the regular default constructor just doesn't do anything. It's basically the same thing as like the one given to you. It's just cat, nothing. But now when you rewrite your own constructor, it basically overrides the default constructor with no parameters. So now you have to use your constructor. Pass in 5 for the age. 5 goes into A, which is the age, and 10 goes to the weight. And then it calls this default constructor and initializes your variables. And you could also create your own default constructor to have any for your own default constructor. Just have no arguments, no parameters at all in your constructor, and you could set it to any arbitrary value. And then you could call your own default constructor by just not including anything when you initialize in your parentheses. This would just call the default constructor of 5 and 100. 10 and 100, yeah, so yeah. That's default constructors. Alright guys, so the whole time we were actually doing this completely wrong. So I'm going to tell you guys how to actually structure your code. So before, when we make the class cat, we actually put the implementation of each function into the declaration of each function. So that actually made everything here in line, which is not something good to have. Also, we put it in the same file as main, which is another thing that it's not good to have. I'm going to actually create a completely new file and show you guys the proper way of structuring your code for classes and objects. So here, I'm going to save this and copy this. So I'm going to create a completely new project. Let's just call this cat project. It's going to create a class with cat project. Okay. So now I'm going to add a new header, new item. Let's call it header. And then we're going to call this cat. So header is basically just where you should put your functions, your definitions, your declarations of your functions. So here, I'm going to take out main. This is the header. So you're not supposed to put the implementations of your functions. So I'm actually going to keep get age and get weight because these are they're accessors, but we can make them inline, mainly because it really doesn't matter because they're only one line of code. I'll take this out also. Take this out. So now I'm going to take this out also. So we're going to have structure our code like this. Let's cut this out. Oh no, whoops. So our code is just going to be like this. Each line like this. And then we're going to make this private to make it more clear. So that we have the inline functions here that have the implementation inside the declaration of the function. And then we have the prototypes of all the functions and constructors that we have and destructors. And this is going to be the header. This is the header file. So we don't need using namespace. We don't need this. And this is the header of the class cat. So now we have our header file. So the header file is basically just all your all your prototypes, all your class definitions, not class definitions, your class declarations, all of that, your instance variables. That's where you should put your header file because people don't need to know the implementation. They just need to know where is the header file. They just need to know like the prototypes of the functions. Now we're going to actually create the implementation. New existing item. No. Add a new item. CPP. We're going to call this cat. So now we have this cat. So now here is where you include your header file. So it's cat.h. Now we include the implementations for our header file. So I'm actually gonna, since we already had our implementations in the other file, let's save all the following. I'll just copy this whole thing and then go back to our previous project. Paste it here. So now we don't need this. We don't need this, but we are going to include implementations. So we're going to copy these, paste them on the outside, delete the main. We're going to copy these, paste on the outside. It says it's invalid right now for now, and then we're going to delete this. So now we have cat. So now we have the header file, which has all the prototypes for all the functions that we're going to implement. So now we're going to implement them. To do that, we do cat that, and that basically says, okay, in the cat.h, we're going to implement these functions or these methods. So this allows you to implement whatever it is, your definitions of your thing. So then do cat : set weight, then do cat : set weight. So now you have all the implementations. So now we have a file for the header file, which has all our prototypes, all the functions that we're going to implement. Then we included the header file inside. We created a new file called cat.cpp, which includes the header file and the implementations of each functions for each prototypes for cat.h. Now we're going to create a main. So add a new item. We're going to call this, I have no idea, source. So now at source, we do hashtag include. Now we're just going to include the cat.h, include iostream. And now we copy the things that we had in main on the other solution. So let's go back, save all. We just copy this main, go back, the project we closed, and just paste it here. And ideally this should still run correctly. Boom. Age is 10, weight is 100. So that's what you should structure your code like. You include a header file that has all your prototypes, all your instance variables for your class. Then you include an implementation file that implements each individual method or constructor or whatever destructor that you have for your class. Then you create another file for your main method, and that's when you add these values. These create your cat object and stuff like that. So yeah, that's how you should structure your code. So before we had inline functions where we included the implementation inside the header file. That's fine for these types of accessors, but it's not fine for, it's not the proper way to structure your code for like the getters and setters and constructors. So yeah, that's pretty much it. And tomorrow we'll talk about loops because we didn't go over that. So yeah, this is how you should structure your code for your objects in C++. And rate, comment, subscribe. I'll check you guys later. Peace.